Okay, this is third video lesson from Cisco ASA training series. In this video session, I will discuss about Cisco ASA ACL. Similar to iOS router, we can use ACL in Cisco ASA Firewall as well. If you come from CCNA level, then you might have some understanding about how ACL works in iOS router. Here we will focus about ASA Security Appliance. Let's see how ASA Security Appliance process the ACL rules. When traffic comes to Security Appliance from any one of the zone, it can be from inside or outside or DMZ. Initially, Security Appliance will check the state table. Then ACL, if no match, it will deny the packet. By default, ASA allows traffic from higher security level to lower security level, as we discussed earlier, without an access list. And return traffic will be allowed based on session table in the ASA firewall. But iOS router never maintained the session table. To verify, I will do the telnet session from router R1 to R2. Telnet 192.168.2.1. This is the IP address of router R2. And I will get into the router R2 through the telnet session. While I got the connectivity, what I will do, I will go to ASA firewall and I will type show connection. Here you can verify TCP protocol is initiated to the IP address 192.168.2.1. It is router to IP address. To the port number 23, it is specific to telnet. From the router R1 IP 192.168.1.1, it is random port number. The connection is initiated from inside to outside. According to this state table entry, when the same traffic return back on ASA outside interface, that traffic will be allowed by the security appliance. Okay, there are two major ACL types. Those are standard and extended. The difference between these two, standard and extended ACL. Standard ACL match the source IP address in the traffic, right? While extended ACL match the traffic based on following information like source IP address and destination IP address of the packet, then the IP protocol number and port number, right? So IP protocol number can be in any of the following protocol like RIP, EIGRP, OSPF, or it can be TCP or UDP. TCP and UDP, this one also will come under the protocol. After we select the protocol, certain port numbers also will be followed up, right? So if I select TCP, according to that, certain ports will be given. For example, HTTP. If it is HTTP, then port number 80 will be matched in the traffic, and if it is telnet, then port number 23 will be matched in the TCP information. Similarly, UDP port also will be matched in the traffic, like for example DNS, right? DNS using port number 53, so this comes under the UDP port, so this informations will be matched in the extended ACL, right? Similarly, if you are using time based ACL, then time range will be matched in the extended ACL. You can apply this ACL feature in various scenarios. The first one is traffic filtering. You can use in firewall commonly to filter traffic using IP access groups index like here. The next one, traffic classification, in order to classify the traffic using match access groups index. The next one is route filtering. This route filtering feature you can use combined with routing protocol to manipulate traffic flows, and in order to reduce the memory utilization in iOS routers. When you come to ACL, there are certain differences between router and ASA firewall. In router, we will use wildcard mask for ACL entries. In case of ASA, we using subnet mask. Next different, iOS router use number for separate the standard and extended ACL, where ASA uses same naming convention for both standard and extended ACL. Okay, let's get into the router R1 in order to verify these two key points. The first one, wildcard mask. So if I want to configure any access list over in R1 router, iOS router, config, then you need to start with the access list syntax, right? Then if I want to go with the standard access list, then I will pick a number in between 1 to 99, then put a question mark over here, permit, then you can permit a specific host or you can permit a specific network. If I select a specific network, for example 192.168.50.0, for this particular network the subnet mask would be 255 3 times, then finally 0, right? So here if I put question mark, they will not ask the subnet mask, instead they will ask the wildcard mask. So wildcard mask, it is inverse of subnet mask. So if I want to type the wildcard mask over here, then you need to put 3 times 0 and 255, right? So this is the method you need to follow up in iOS router, right? But if you want to configure access list in ASA firewall, whenever you point out the specific network in destination or source criteria, then you need to point out the subnet mask over here, not the wildcard mask, like this, right? So it is not acceptable over here, right? The same way, if you want to go with the extended ACL in iOS router, then again you need to go with access list, then you need to pick a number in between 100 to 199. So if I just put 110, straight away this iOS router will come to know, okay, I'm just going to configure the extended ACL over here. So extended ACL will work based on certain criteria: source IP address, destination IP address, IP protocol number, port number, those kind of information, right? So when I type this access list, everything you will type one by one. For example, if I put permit, then straight away in the first argument they will ask the protocol. If I want to select the protocol, for example TCP, right? In TCP protocol, certain port number you can select, for example HTTP. So that port number information you can give finally, right? So once you give TCP, here you need to select the source network address. For example 192.168, from this source network you will send the packet, right? Here again you will put the wildcard mask, right? Then destination IP address you need to mention over here, right? If I go with any network, for example 192.168.40.0 something, right? Then again you will put the wildcard mask, right? Then finally port number you will select equal to what TCP protocol you will use over here, right? So all this information will come under the protocol called TCP, right? So if you select the UDP, then according to that the protocol will be changed over here. For example, if I select, this would be the HTTP traffic, right? Either you can point out through the port number. In ASA firewall we will use net mask. And another thing, there is no any number in order to separate the standard and extended ACL. Instead we will use the same naming convention for standard and extended ACL. Okay, by default traffic originating from lower security level to higher security level will be denied without an access list, right? So if you want to bypass the security level functionality, then you can use the ACL in the ASA firewall, right? So without ACL, ASA firewall do their jobs properly, right? So if you want to give some exception, you can bypass the functionality of the traffic flow by using access control list in the ASA firewall, right? According to the method you assigning the ACL in security appliance can be categorized as inbound, outbound and global ACL, right? So you can have one inbound and one outbound ACL per interface along with one global ACL. Without global ACL order of processing, let's say for example your traffic coming from 0 security level to security level 100, right? So your traffic coming from outside to inside, right? The first thing first, ASA firewall will check the state table as I showed to you earlier. The second thing, it will check the ACL, and if no match entry it will deny the packet, right? So this is what the order of process without the global ACL, right? So let's switch over to another diagram in order to understand the inbound packet filtering in ASA firewall. Okay, with the help of this diagram we will start to configure the inbound packet filtering in the security appliance. Before we get into the ACL demonstration, you should know two things about this diagram. So far we discussed about the connectivity among devices connected to security appliance directly, such as router R1, R2, R3, as we see in previous picture like here. right? So in this picture, all three devices are connected directly to the security appliance. That's what the testing was easy. Through this diagram, we'll check the connectivity among end devices such as host A, the PC in the internet for example, and PC1, it is inside our organization, right? Here in router R1 we have another subnet especially for PC1 network, right? In this case, if I want to route any traffic from the security appliance side, then we need to create an additional route entry from the ASA firewall using the command called route inside. The same method you need to follow up for all the existing network in the router R1, right? So currently I have only one network. For this network, if I want to route the traffic, then I need to use the command called route inside. Second thing, network address translation. I have configured a certain configuration related with network address translation in this security appliance, right? Our fourth video in ASA training session going to be related with basically a network address translation. For this demonstration, slightly I will explain what I did in this demonstration initially before we start the ACL. Initially I just create two network object with this command, right? With the name LAN and web subnet. LAN for is specific to this particular network and web subnet for PC1 network. Then finally I bind this network object with the net rule in the security appliance, right? So this can be done through the ASDM graphical user interface, or either you can do it through the console. Okay, you can verify it using show run command in ASA firewall. So I have created both of these network object over here. Then I bind that network object with the net rule, right? So, and one more thing, we need to create a route entry for this particular subnet from the ASA Security Appliance. That is the subnet of PC1 network, right? So in order to create the route entry, config route inside, then we need to point out the PC1 network. Okay, 172.16, then 2128/27 subnet mask 255.255.255.224, right? Yes. Then if I want to send a packet from ASA Security Appliance to this particular network, then where do I want to forward the packet? That's what I have to give over here. So I need to forward the packet from Security Appliance to router 1 IP interface, which is 172.16.15.131, directly connected to the security appliance. Okay, so I'll just give the IP address 172.16.15.131. Done, right? So this command also must be given from ASA firewall side in order to test the default behavior of ASA firewall. Thereafter only we need to check the ACLs in the security appliance. Okay, so let's first of all let's verify from PC1 will I be able to reach to the host A in the internet. Before I get into the PC1, I will just enable the logging in ASA firewall. That way when any log messages I got, then I can see over here logging console debugging. I forgot to say one more thing. Whenever you do something from the console, the same thing will reflect to the graphical user interface over here, right? So we did two things. One is we create the static route over there to point out the PC1 network, right? So according to that you can verify over here device setup and just go to routing, and under the routing you can see the static route for that particular network from the security appliance. Then if you click static route, here you can verify inside network we have mentioned over here in the ASA firewall. Also we create network object. That one you can verify by clicking the firewall, then just go to object over here, right? Then you click the network object. Here two object we create, that is LAN, other one is web subnet, right? Then we bind these two network object through the net rule over here. This graphical user interface also you can follow in order to do the configuration, right? So it will reflect vice versa from graphical user interface to console, and again from console to graphical user interface. Certain things you must know about ACL in firewall. The first point is, if duplicate access control entry found in ACL, the packet never evaluated against the second ACL, all the packet match the first ACE. Okay, so what does it mean? Here I have pointed out two ACE access control entry in the same access list, right? But the access control entry is same to same except these two statement, right? So the first access control entry is specific to permit statement, the second one is deny, right? So if these two ACE, if I mention in the access control entry, the second one will not work to us. This is what this point, right? Okay, second point, do not define an access control entry to permit specific traffic from higher security level to lower security level, because it disables the implicit permit. So that's what I said to you earlier. The security level 100 to 0, the ASA firewall can route the traffic. So according to that, you no need to give any permit statement over there, right? So if you give any permit statement for a specific host, also for a specific protocol and port number, automatically remaining all traffic will be blocked from inside to outside, right? So these kind of things you should not do. Instead, if you would like to stop any traffic from inside to outside, that thing you can do, right? Okay, next point, ASDM define an ACL name using interface name underscore access underscore direction as the standard format. What does it mean? If you create an ACL using ASDM graphical user interface, then standard format for the ACL name will be interface name, then access, then direction, right? So which direction you are creating an ACL, that will be mentioned over here, then the access normally will be given, then interface name, right? For example, if you create an ACL in inside interface as an inbound direction, then inside access in will be given, right? Similarly, if you create an ACL in inside interface but outbound direction, for example outbound direction, then here you can see outbound inside underscore access underscore out, right? So this is the way ASDM interface automatically will give the name for the access control list if you create an ACL using graphical user interface, right? Okay, initially let's enable the logging in ASA firewall. That way if you get any log messages, simply we can see logging console debugging. This is the command, right? And currently in ASA firewall there is no any ACL assigned, so according to the default behavior this ASA will work, right? Whatever the traffic comes from inside to outside will be allowed. So in order to test it, I will get into the PC1. If I ping from PC1 to my host A PC in the internet, I will be able to get the ICMB reply, ping 172.16.5.100. You will be able to get the reply from there, which means from high security level to lower security level you can send the traffic, right? If you try in reverse order, you will get host unreachable message, right? 172.16.20.131. this is the IP address of PC1, right? So this will be failed. Okay, now let's create an inbound ACL in order to block the ICMB traffic from PC1 to host A in the internet, right? So I will just give the syntax access list, then question mark, then you need to provide the name for the ACL. I will provide inside because I am going to assign this ACL in the inside interface of the ASA firewall underscore, then I will just provide access, then I will provide info inbound ACL, right? So the same way the ASDM is using, right? Okay, then again put the question mark over here. I'm going to use the extended ACL, then again question mark, then I'm going to deny the packet. So deny option you need to choose, then which protocol you need to use in order to deny. I will choose the ICMB protocol over here, right? ICMB, then host, from which host you want to block the traffic. I'm going to select PC1 IP address 172.16.21.31, again for which destination, that is IP address of host A in the internet, right? So I'll just choose host, then 172.16.5.100. that's it. So according to this, it will block ICMP traffic from PC1 to host A. Okay, now you have created the ACL, but it will not work until you apply the ACL to the interface, right? So in order to apply the ACL in the interface, you need to use the command called access group. Then you need to provide the name of the ACL over here, the same ACL name. Then you will use it as an inbound ACL or outbound ACL. I will use it as inbound ACL because traffic going from security level 100 to 0. In then interface, for which interface you are going to assign this one, in inside interface, right? Enter, right? So now ICMP traffic will not work from PC1 to host A. Let's get into the PC1 over here. Then if I try to ping from PC1 to host A in the internet, I am unable to ping the host A in the internet. Okay, now I will do the telnet session from R1 router to ISP router. Telnet ISP router IP address is 172.16.10.131. So I am unable to do the telnet session as well. According to my theory, it should disable the ICMP traffic from PC1 to host A in the internet. Not only that one, even remaining traffic also will be blocked because of implicit deny at the end, right? So you have to explicitly give the permit statement in the ASA firewall. So in order to give the permit access control entry, you need to go to the show run access list. Here you can verify only one access list we have created. According to this, it will block PC1 to host A, but at the same time remaining traffic also will be blocked because of implicit deny. Show access list, then access list name inside underscore access underscore in, right? According to this, it will show how many elements are there in the access control list. Only one element. If I want to add additional access control entry in the same ACL, I can edit this access control list, right? So how you will edit? Access list, the name for the access list inside underscore access underscore in. Then I will select line 2 because line 1 already there, that is deny statement. So I will just create an additional line 2. Then you need to permit the traffic for remaining all, right? So permit IP any, right? So this is the command you need to give at the end in order to allow the remaining traffic from our inside to outside, right? So now if you give show run access list, then you can see 2 access control entries, right? So what is the usefulness of this editing option? If you don't have this editing option, what you need to do, you need to remove the ACL from the inbound interface. Then you have to remove the ACL and reapply the ACL. So these kind of things you have to do if you don't have these options, right? So this is one of the best options that you can edit the existing ACL in your ASA firewall, right? So now if I try to ping from R1 to ISP router, definitely I will be able to ping the ISP router from R1 router. Okay, sorry, telnet. Now it is successful. Okay, show connection. If I type now what they are giving, now I do the telnet session from R1 to ISP router. Okay, so what they are saying now here, TCP protocol is initiated from inside IP address 172.16.15.131, that is this router R1 IP address, and from the runtime number it initiated to the port number 23, that is the telnet port number, to the IP address of ISP router, that is 172.16.10.131 over here, right? So this kind of information you can see from ASA firewall once you enable the debugging. Okay, now let's block the HTTP traffic from router R1 to ISP router. Currently I don't have HTTP service enabled in ISP router, so I will just enable the HTTP service IP HTTP server. This is the command you need to provide in order to enable the HTTP service, right? Then from R1 router I will just telnet to HTTP traffic, telnet 172.16.10.131. This is the IP address of this ISP left side interface. Okay, you need to type the port number 80, right? So the connection is initiated and it is successful. Okay, so if I want to block this traffic from R1 to ISP router, then you need to again edit the access control list, right? Okay, if you give this command, it will say how many elements are there in the access control list, right? So in order to modify this one, I will type access list inside access list, then I will give the name for the access list inside, then you need to type line, then I will just put in between this line 1 and line 2. So once I create this access list entry as line 2, automatically this entry will become line 3, right? So I will just put line 2. Then you need to deny the traffic. Deny, you are going to deny which traffic? TCP. HTTP is coming under TCP protocol. TCP you will deny from IP address. I will consider this IP address as a host, right? 172.16.15.131. Then to the host IP 172.16.10.131 equal to HTTP protocol. Enter. Right now if you see show access list inside access in, then you can see all 3 lines in the same access list, right? So first one will deny the ACMB traffic from PC1 to host A. The second one will deny the HTTP traffic from R1 router to ISP router. Then remaining all traffic will be allowed. So now if I try from router R1, so it is currently unsuccessful because of this deny entry. Okay, so this ACL will be considered as inbound ACL. The same thing you can verify from the ASDM interface as well. If I go to ASDM console, I will just refresh the interface. Okay, then I will get into the advanced. You can use this interface to create ACLs. So if I click the ACL manager, here you can click add ACL, for example 123. Okay, then under 123 access control list you can create access control entry, for example. Then you have to choose whatever the object you want to select and those kind of thing, right? So here also you can select. After you click OK, access control entry also will be selected. Okay, so this is the method you will use in order to do through the graphical user interface. Now let's configure the outbound ACL. Before we start the outbound ACL, you must understand how you're going to identify the inbound and outbound ACL. Don't look at the zone name, right, in order to consider it as inbound or outbound. So let's say for example the traffic is coming from inside to outside, but you assign the ACL in the inside interface, right? It will be considered as inbound ACL. And again the traffic is coming from inside to outside, but you assign the ACL in outside interface, then it will be considered as outbound ACL. So you should see the direction where the packet is moving. If the packet is reaching to the firewall, it will be considered as inbound ACL. If the packet leaving the ASA firewall, then it will be considered as outbound ACL. Okay, now let's configure the same access control list as outbound ACL. Let's come to this picture. First of all, I will just give the command show access list. Then the name for the access list is inside access underscore in, right? This is the name. Okay, here you can see there are 3 elements, right? So I'm just going to rename the ACL and then I will assign the ACL in the outside interface of the ASA firewall, right? So how are you going to rename it? Access list, then I will provide the previous name of the ACL, right? Then rename. The renamed ACL going to be outside interface. I'm going to assign access outbound ACL because it's going from inside to outside. That's what outbound. And essentially you don't need to rename the ACL. Instead we did by according to the name we can identify in which interface we have assigned the ACL, right? So we have changed the name. Now let's enable that access control list in outside interface of the ACL firewall. So in order to do that, I will just type the access group syntax, access group. Then we need to point out the name of the ACL. The new name for the ACL is outside underscore access out, right? Then again question mark, then out for outbound traffic, right? So I will just assign this ACL as a outbound ACL, so I will just put out. Then you need to point out in which interface you need to do it, right? So interface outside. Okay, currently all my ACLs are under inside interface, so once I refresh it will be available under outside interface. Okay, okay, now all three entries came under outside interface over here. Until now, when we configure the access control list, initially we create the access control list, then we bind that ACL in the interface of the ASA firewall. It can be inside, outside, or DMZ. So this will be called as interface level ACLs, or traditional ACL in another word we can call. Beginning with software version 8.3 and newer, they introduced the global ACL. Global ACL is something that you will not bind the access control list in the interface. It will be assigned globally in the ASA firewall. So with global ACL, order of processing is different, right? So initially let's look at the normal order of processing of the inbound ACL. When traffic comes to ASA firewall will look at the state table. Is that connection already initiated or not? If so, it will allow the packet, or it will process the packet according to the access control entry in the inbound ACL. Remaining all packet will fall back to implicit deny in the inbound ACL. In case if you have global ACL with the inbound ACL, after the inbound ACL, the implicit deny from the inbound ACL will be ignored and it will fall back to global ACL. Then it will process the ACL according to global ACL statement, right? So first inbound ACL, okay, second global ACL, a third outbound ACL. Okay, so in which scenario this global ACL is appropriate in the companies? When you have multiple interfaces connected to ASA firewall, then you can apply the global ACL, like more than 3 or 4. If you have outbound ACL, then the source IP address is the real IP address of the host or network, not the translated address. When do the demonstration we will understand this one. For the inbound ACL, destination IP address has to be the translated address for any of the version before 8.3, older than 8.3. But whenever you use ASA version 8.3 and newer, then you have to use the real IP address for the destination. This is the option we are using in our ASA firewall. When you have a DMZ zone, probably you want to access some of the server init from the internet. In previous demonstration, we checked the traffic flow from inside security level of 100 to outside zone security level of 0. By default, the traffic can flow from inside to outside zone because of higher security level in the inside zone. But we block the traffic HTTP and ICMP, and we assign the ACL in the inside interface of the ASA firewall. But what we will do here, we will test the connectivity in between DMZ and outside. DMZ security level 50 and outside security level is 0. Here we will allow the connectivity from host A in the internet to web server in the DMZ zone. As per firewall consideration, outside zone networks will be considered as globally routable. Okay, what we are going to do here, we will allow the HTTP traffic from host A in the internet to the web server in the DMZ zone, right? So that is server 1, and we will block remaining all traffic from the outside interface to DMZ zone. So first of all, I will create a network object in the firewall. In order to create the network object, I use the ASDM console. Click firewall, then go to object, then network object, then you have to click add network object, right? Then you need to provide the name for the network object, for example HTTP server. Then you need to provide the IP address of web server inside your DMZ zone 6.2. Then click OK. That's it. The same way I followed up in order to create the HTTP server network object in the ASDM console. Okay, then let's create the ACL access list. Initially I will create this ACL as an inbound ACL rule, so I will just provide the name outside underscore access in, right? Inbound ACL rule. Okay, then extended, we will choose extended. You need to permit the traffic from outside to inside. Okay, before we create this ACL, let's verify the connectivity. Okay, this is my Linux box with the IP address of 192.168.6.2. This is the web server. So I will just verify the connectivity from DMZ to outside. Will I be able to reach or not? So if I ping 172.16.5.100, definitely the ping message will be successful. Because of what? This is high security level. Reverse order, if you try to ping, definitely it will be unsuccessful. Because of what? Lower security level, right? So now I'm trying to do this one from the internet to web server. The internet host IP address is 172.16.5.100. so if I ping 192.168.6.2, it will be unreachable, right? Because of this lower security level. Let's continue the access list. Permit, I'm going to permit the traffic. Permit which protocol we are going to use, right? So in order to access the web server, normally we are using port number 80, that is TCP protocol. So I will choose TCP host 172.16.5.100. this is the source IP address. Then the destination IP address, I'm going to select the object because we have already created an object, network object with the name of HTTP server, right? So I will just choose the object. Then you need to give the network object name, that is HTTP server space question mark again equal to TCP, which protocol we are going to run, that is HTTP protocol. So you need to choose www, right? Or either you can type AT or HTTP. So let's bind this access list with the outside interface of the ASA firewall as an inbound ACL rule. Okay, access group, access list name, right? Type in. As an inbound rule we are going to use. So you are choosing the inbound rule. This is just a name. In order to make it an inbound rule, you need to select in. Then again, in which interface you are going to do this one? Interface outside. Okay. So once you type this command, you will be able to access the web server from the host A PC in the internet. Okay, let's type the IP address of web server in the URL, right? When you type the web server IP address, you cannot type the private IP address, which means whatever the IP address we are using in the DMZ zone, you cannot type here. It is not globally routable. As per our diagram and as per our ASA firewall consideration, the outside IP addresses are globally routable. So you can pick the outside IP address, which means gig0/1 IP in the ASA firewall outside interface, right? So I will just type http://172.16.10.130. that is the IP address of gig0/1, and colon port number 80 we are using for this particular protocol, right? Port number 80, enter. So you will be able to get the website from the server one in the DMZ zone. Okay, so this is successful. Remaining all traffic will be denied because of implicit deny at the end. Even explicitly you no need to give the deny entry at the end of this particular access list, right? So this way we can test, right? Similarly, let's test a telnet session from host B. Ping 172.16.10.130. Then capital P for protocol number 6, that is specific to TCP. In TCP, which port number you will use? That is simple P. Then 80, right? So here we will not use telnet port because we will use the port 80. Anyway, this is open port. Enter. Okay, timeout message you will get. This is open port for host A, not for the host B, right? That's what host B cannot reach to the DMC server using this particular IP address, right? So now we will enable the HTTP service for the host B PC as well from the internet, right? So how are you going to do it? For that, let's verify the existing access list in the ASA firewall. Show access list outside underscore access then in. This is the access list we create, right? Currently one element is there. What is the element? Access list outside access in line 1 extended permit TCP host 172.16.500. this is the host A IP address. So we will enable this one for the host B as well. So how are you going to do it? While we are in this access list, how are you going to edit? Okay, access list, then you need to select access list name. So this one, access list name, then line 1 extended, then permit the traffic specific to protocol number 6, that is TCP. Then you will select this particular host. IP address is 172.16.501. so I will just type host 172.16.501. then for which host you will route the packet, that is HTTP server, the object which we create. So what is the object name we create? Object, you can give the object like this, object, you can choose object, then object name HTTP server. Okay, here one more thing you need to edit, not line 1, line 2, because already line 1 that is for host A, this is line 2. okay, that's it. Now I am able to do the telnet session, HTTP session from host B as well. Okay, connected, right? So you see it is connected, it will work. The same way if you try to get the connectivity through the telnet, I am unable to get because there is no telnet connection enabled for even host A or host B, right? So timeout. Okay, let's create the same ACL using ASDM interface, but this time we will not create the interface ACL. Instead we will create global ACL through the graphical user interface. So before that we need to delete the existing ACL in the ASA firewall. So I'll just put the command show run access list. Okay, these two ACL must be deleted, right? So in order to delete this ACL, before I need to delete the binding, which means once we create this ACL, we bind this ACL to the outside interface as an inbound ACL. So that must be deleted initially. So in order to delete that, I will just put the show run command initially in order to verify which one is it. This is the one initially you need to delete, right? I will go to global configuration mode. No, right, enter. So you have deleted the binding, then you need to delete the access list. Show access list, same access list you will delete. Okay, these two entry you will delete. Okay. Okay, best method, just copy it to notepad. Then you type no in the front. Here also no. Okay, now again if you verify show run access list, still it is there. Okay, let's delete this way. No, enter, right. Now it is removed completely. Let's create using ASDM interface. Before we create the ACL rule, let's verify what network object and service object I create initially. So if I click network object, I can see I have already created one network object with the name HTTP server for the IP of web server in the DMZ zone. Then service object I just create for the protocol TCP with the port number HTTP. Now let's assign the access rule. Here we will create the access rule, as well as we will bind the service object and network object over here, right. So we will create this one as a global ACL as we discussed earlier. So in order to create the global ACL, we will click add, then you need to select any. This is the key point for creating the global ACL. Then you need to select source IP address from which source we are getting the traffic, that is our host A IP address in the internet. What is that IP? 172.16.5.100. Let's verify one time. .100. Then we will select the destination, that is web server IP. We have already created the object network over here. I will just select that one. Then you need to select the service which you have already pre-created, that is over in the top, HTTP. Okay, right, option. Okay, now we have created the ACL rule for the host A PC. Then similarly we need to create the ACL rule for the host B PC. How are you going to create? Again, I will just go to add, any, permit, then source 172.16.5.101. then you need to select the destination, that is HTTP server, which is our web server, then the service. Okay, right. Now we have created the access rule. Here, while we are creating the ACL, at the same time we will assign the ACL globally. Then you need to apply it. Done, right. Okay, now let's verify from the host A and host B again. I'll just get into the host A, right, go to here. Okay, we cannot trust this one. I will just close and reopen it. Okay, it is success. Okay, while we are accessing the port 80 in the web server 192.168.6.2, we can get the information from the firewall as well, through the graphical user interface as well as through the console. So once again I will connect it to port 80 in the specific server in the DMZ zone, right. And similarly from my host APC also I will just connect again. Now it is success. Here also it is success. The same thing you can monitor from here. If I type show connection all, here you can see 2 connection already being initiated. So here you can final connection you can see basically, right. TCP connection being initiated from outside zone. The host IP address is public IP address is 172.16.5.101. To the random port number, from the random port number to the zone DMZ zone server 192.168.6.2. this is the server, and port number 80. Okay, in traffic filtering normally we will use extended ACL in order to match source destination IP, port number, protocol, all those kind of things, right. So we never use standard ACL in traffic filtering, but there are certain use case scenarios in order to use the standard ACL. One is split tunneling for the remote access VPN. In upcoming lessons we will discuss about remote access VPN. In that scenario we can use the standard ACL. The next thing, route redistribution. Let's say for example in your company, your organization is very big, you have multiple routing protocol you are using using in order to manage your networks, right? In that scenario, sometime you will use the route redistribution in order to redistribute one routing protocol into another routing protocol. On that case, you will use the standard ACL. Okay, next, object group. Earlier we covered about objects. You can create network object, service object. In order to simplify the ACL management, what you can do, you can create the object groups, right? So in that object group, you can collect a number of objects inside the object group. Let's say, for example, in your organization you have dozens of servers and more hosts. Then best option to configure the object groups in your ASA firewall. Okay, according to my previous diagram, here you can see 3 servers inside the DMZ zone. Similarly, I have 2 hosts in the internet. Then I can allow these 2 hosts to access the services from the DMZ zone servers. In that case, what you can do, you can create access group with these 3 servers inside the DMZ zone. Similarly, you can create object groups for the internet host with the host A and host B, and also you can create service, then you can group them together in the object group, right? So this is the way you will create the object group. Then thereafter you can bind that object group in the ACL access control list, right? So if you don't have object group, then it will increase the number of access control entries in the ASA firewall. For these 3 servers, you will create 3 access control entries for each and every services, and similarly for each and every host, right? So you can calculate the number of access control entry by multiplying the servers by 2 hosts and 3 services. Altogether 18 access control entries you need to create in ASA firewall, right? But if you use object group, then you need to create only 1 access control entry inside the ACL. You can create the object group according to the group types, right? Like protocol, right? You can collect a number of object group similar to TCP protocol. And services, whenever you create a service group, then also you need to consider the protocol. Like whenever you collect a number of services inside the service group, then you can go ahead and select from TCP only, or you can select from UDP. So next thing is the network, right? When you come to network, then you can create the network object group, like for the internet host, and similarly for the web server inside your DMZ zone, right? Similarly ICMP types. So you cannot mix them together like protocol and network inside the one network object group. You have to do it individually. Okay, let's create object group for ACL configuration. I will start with service object group. Object group. If you put the question mark over here, then you can create the object group from certain criteria like network, protocol, ICMP type, security, service, user. So I will start with service, right? Service. For the service, we can give a name. I will just give a customized name, http_telnet. Under this particular group, I am going to use 3 services, HTTP and telnet plus HTTPS service. Okay, so once I enter, then it will allow you to add the services, service object. So I will just go with the service object dash service object. Then what service you are going to create initially, I'm just going to select the TCP. Okay, under TCP you need to point out in the destination what are the service you're going to run, right? So I'll just select destination, then which service equal to HTTP service, right? So you need to type HTTP. And similarly for the HTTPS, I'll just use the up arrow key and HTTPS. Again I will use the up arrow key, then I will make this one as telnet. Okay, right, that's all. You have created the object group for the service. Okay, you can create the object group for the network. So first of all, I will start with the internet host. Object group. Then this time I will choose network. Then for the network I am going to give the name internet host, internet_host. Then the host network object, I will select network object. What are the object you are going to create? I will just point out 2 individual IP address, not the network. So I will just select host instead of network. then those two hosts you need to select 172.16.5.100 host A IP, then host B IP 5.100.1, right? So I'll just type the IP address of host A 172.16.5.100, then up arrow key, then type 100.1. Okay, now we have created the object group for the internet host, right? So we can verify using show run command, or either you can verify using ASDM console, right? So I will get into the ASDM interface, then we will verify these internet hosts are present or not, right? So after that we will create the object groups for the DMZ server. If I want to see the object group which we have created, then just you need to click configuration, firewall, then you need to expand objects, then under the network objects you can see the internet host object group, right? So if you want to see the service object groups, then you can go under service object, then you can click the plus icon over here, then you can see all three services which we have created. So now manually we will create the object group for the DMZ server. Okay, click add, then network object. I'll just give the name for the first server, server 1, right? The server 1 is basically a host, not the network. Then we need to provide the IP address for the first server, that is 6.2, second server 6.3, third server 6.4, right? So 192.168 6.2, right? That's it. Click OK, and similarly you will create two more object entries over here, right? I will add network object, then server 2, 192.168 6.3. Okay, then again click add network object 3, 192.168 6.4. click OK, right? Then you will create the object groups for the networks, right? So I'll just go to add mark, and then I will select network object group. Then you need to select the server which you have created under the object. First server 1, then server 2, server 3, right? So these things I will just put inside the object groups, name called DMZ server, right? I'm just going to give the name for the object group DMZ servers. Click OK, then you can verify from here, right? So it's still not done. You have to click apply in order to save these changes. So once I click apply, it will show all the object which we have created using ASDM console, as well as it will show all the object groups which we have created, right? So we have created only one object group, that is the DMZ server. Then we move those server individual objects inside the DMZ server. Okay, right? Just send this one to make changes over there. Then you need to create the access list. When you create the access list, in the access list just you will use only one access control entry. So I will just go with the inbound ACL rule. So for that purpose, first of all I will just create the access list. Okay, access list. Then you need to provide the name for the access list. I will just provide a customized name, outside access in. As an inbound rule we are going to use. Okay, once you type permit, and if you put the question mark, then they will initially ask about the service which you are going to add, right? So we have already given the name for the service object group. So I will select object group, then you will provide the name for the service, that is http:/telnet. Then once you put question mark, they will ask about the source IP address. For the source IP address also we have created one object group, type object group. The object group name for the source address, internet host. Okay, that we create over here, internet host. Okay, internet_host, and the destination DMZ servers. Host. Then the destination also object group. DMZ servers. Okay. That's it. Then you can verify again by using show run command. We have created the access list. but still we didn't bind this access list as an inbound ACL rule in the outside ASA interface. Okay, so how are you going to bind it? Access group, access list name outside underscore access underscore in. As an inbound ACL rule we are going to use in the interface outside. Okay, that's it. Now you have some understanding about object groups. By using this object group you can simplify the ACL management. That's all for this video. The next video lessons topic going to be network address translation. In that lesson you will study certain net categories and how to use the net along with port forwarding.